More chapter 20 to assess, and this is question 4. Right, parallelogram ABCD has AD as 5, okay, thank you. It's got AC as 8, and the angle ACD, or rather ADC, is 57, so that's that. So I know that's 5, for example, and I know that's also 57. Not that I'm going to need it, but there you go, that's just information. Calculate angle ACD. Alright then, ACD. They want that one. So I know that this angle 57 corresponds to the opposite length of 8, and I also know that from my sine rule that this length C corresponds to the angle C that they want, ACD. So it's the C part that they want. Okay, let's just set up very simple sine rule and we'll get our marks. So what I want I put on top. So I want sine capital C divided by his corresponding or opposite side. It's just like comparing the sine of 57 degrees divided by his corresponding or opposite side of 8. So I've set up the equation now. All I need to do is to take my 5 next door and multiply. It's dividing over here, isn't it? So I've got sine of the angle I want is sine 57 all over 8 multiplied by 5. Let's just get an answer for that bit. So sin 57 divide by 8 times by 5, bam, gives me 0.524169105. So therefore my angle C is going to be, let's highlight it in black, is going to be shift sine of that. So shift sine is going to give me 31.6 degrees. Okay, and that's lovely and easy. Okay, straight application of a sine rule. And again, I don't know why they started spinning us a story about parallelograms and what have you. It's quite unnecessary, because it just may as well give us just a a triangle and off we go. But there you go. That's all the question says. Next one, simple question. I'll stop the video with this because the remaining one's going to be complicated and involved. So this is worth just a video on its own with the previous question. This is question 5. It's boring. Calculate the area of this triangle. Well, since it's the assess, it's the review, let's just do it properly. So the area is going to be half AB sine C. Again, you don't write that down in the formula in your exam because there's no marks for copying from the front cover. So this is where you get your first mark. Area equals half times that length times the other length times the sine of the angle that they give you, and then you just hit equals on your calculator and just do it. So 0.5 times 8.1 times 11.2 times the sine of angle 84 degrees. Are you ready? We've got 45, oh not 54, 45.1 meters square. So I'm happy with that. I've not done a signature for ages, so let's just do that. This is me, Mr. C, signing off. Alright, easy peasy, 2 questions, all grade A. Lovely easy questions. Back to the assess, continuing. Question 6 is a lovely question. We had one of these in the main chapter itself. It's worth doing one in the assess. If you get one of these in the exam, number 1, don't panic, but there's an awful lot of work to get the answer. So here we go. Cuboid, and they give us all the lengths. I've got BC is 4, so that is 4 right there. CF is 5, so it's 5 right there, and EF across here is 7. Let's put in some other bits and pieces. Calculate angle BDF. So really, let's go for blue. They really want this angle here, B to D to F. Let me just complete the triangle. This is what we've got, alright? And they want that thing, red. They want that angle right there. Well, as I said in the previous example back in the main chapter, we don't have any lengths DF, we don't have BF, we don't have BD at all. Therefore we have to calculate them using Pythagoras. So here we go. Well, if that's 5 across there, let's go back to black so it stands out. If that's 5, vertical height 5 of the cuboid, that's 5 as well. If that's 4, then so is that, and this is also a 5, and this is also a 7, and that going back, AD is also a 4, and B to A to B is also a 7. So that's all I need really. So if I want to pick on this one at the front here, I can work out DF by multiplying the 5 squared and 7, well sorry, adding 5 squared, 7 squared, and hitting the square root button. Let's do it in one go quickly. So I need to know DF. So DF is going to be, using Pythagoras, 5 squared plus 7 squared, and then you press the square root button on the whole lot. So what have we got? 25 and 49. So 25 plus 49 is 74. Square root of that is going to be 8.6. There it is, 8.602. I won't round it off too much until the very end. So DF is going to be 8.602, and that's going to be in centimetres. So I've got DF. Let's pick a different one for with a different colour. I've got to work out BD. Now, so with BD, I'm playing with the side of 7 and 4. Okay, so that's a right angle looking up top. If you look on top, I've faced ABCD, got right angle there and there because it's a cuboid. So let's just do this then. BD. So BD or DB is going to be 7 squared plus the 4 squared, and then we're going to hit the square root button. Just doing it in one step. This is just grade C. So we've got 49 plus 16 equals something, 65, and then we're going to root that, and we have the length of BD being 8.06. Oh, okay then, 8.0622. So there you go, 3dp is good enough. That's that one there. And the last one we're going to work out is FB, which is down in blue. So what's FB all about? Well, it's the hypotenuse where we have the base of 4 and the height of 5. So here we go. So BF for FB is going to be 4 squared plus 5 squared, then square rooted, and that's going to give us 16 plus 25 equals, we're going to root that right now, root of 41 gives us 6.403, 6.403, and that's in centimetres. So I've got these 3 lengths here. Now let's try and write them in as best we can in a different colour. So I've got DF is, well, that's impossible to read, I'm going to have to go red maybe, let's do red. I've got 8.602, no sorry, DB, where's that? That one there. That's going to be 8.062, make it stand out. DF is going to be the top one, which is going to be 8.602, and this one opposite here is the BF, which is 6.403. So again, I've got 3 lengths that I've calculated. I've not over rounded. I've gone to 3 decimal places. So I've got 3 lengths, and I can work out the angle D. In other words, angle BDF, the one required. So look, angle D links to this opposite side 6.403, the side BF. Therefore, if you like, the side BF is our A side, the side that we start with. So let's just jump straight in black and bold. So here we go. I've got 6.403 squared equals the other 2 side squares, 8.602 squared plus 8.062 squared. Okay, so it's the leading one squared equals the other 2 squared. Take away 2 lots of the other 2, 8.602 multiplied by 8.062 multiplied by the cosine of the angle we want. So I can call it cos BDF. Why not? I've labelled it in a diagram to show the examiner that I know that he knows which one is asking me. So I can now work it backwards. Again, this horrible negative term here should all go next door and get added. And this little 6.403 square thing can go with his little brothers on this side and get subtracted. So let's just rewrite it around the way that we like. So I've got 2 lots of 8.602 multiplied by 8.062 multiplied by the cosine of the angle that we want, BDF, is that and that, 8.602 squared plus 8.062 squared minus, there it is, that little one, 6.403. 3 squared. Let's just work out the numerical bits. We do that little bit now, and while we're at it, we'll do that little bit as well on the other side. Why not? So we've got 2 times 8.602, 2 times 8.602 times 8.0, times 8.062 equals, I make that, go back to black, stands out, 138.6986 times the cosine of the angle we want, BDF, and that equals, I'll do this in one step on this side, I think, not difficult, 8.602 squared plus 8.062 squared, take away the little one, 6.403 squared, hit the button and trust I've pressed the right buttons on the calculator, 97.9918, etc. So the cos of our angle is going to be 97.9918 divided by this horrible thing, 138.6986, and let's just do that quickly, divide that by 138 spot 6986, and that equals 0.706509. That'll do. I'm going to go shift cos anyway, so it doesn't matter how much of this I write, and therefore the angle we want I'm going to shift cos now, so shift and cos, bam, that gives me 45.048. So I'm going to go for 45 degrees exactly. One decimal place, 45.0. I don't like the look of that. How about 45 and that's your lot? I'm going to stop there. That is a very, very rich, very, very involved video. There's only one question I want to do left to finish off the assess and to finish off the whole of chapter 22 therefore. But that deserves a place in its own video catalogue, and so I'm going to stop there. You study that one, it's a lovely one, isn't it? I really like it. I actually quite like the colours as well. Anyway, see you later.